So we'll be talking about factors affecting the rate of chemical reaction. Why? Since we have talked about the rate of chemical reaction, how slow or fast the reaction occurs, then we need to know what are those factors that can influence the rate of chemical reaction. Factors which can increase the rate of chemical reaction or which can decrease it. So they are important. These factors, they are have a concentration. Let me refill this. Okay, factors affecting rate of chemical reactions. So these factors are you have what you call concentration, stroke pressure of what? Of the reactants. Of the reactants. Then we have temperature. So this temperature is the temperature of the reaction system. Then we have what you call surface area that is of the reactant as well. Of the reactants. We know reactants are the chemical species that are chemically interacting. Then we have presence of catalyst, presence of catalyst. Then we have intensity of light or light intensity. Then we have nature of the reactants, nature of the reactants. So take note of them. Then we will be taking them one after the other to explain. So, like I said, these factors they have the ability to influence how the speed of a reaction. Understand? So, in the sense of their increase. So, when these factors are present in much quantity, when they are increased, then how do they affect the chemical reaction? So, some of them, of these factors, when they are high, then they will lead to increase in the rate of chemical reaction. Like high concentration, high pressure, they will increase the rate of chemical reaction. So they will make reaction happen faster. Then high temperature also does the same. So the higher the temperature of the reaction system, then the higher the rate of chemical reaction. Then increase in surface area of the reactant will increase the rate of chemical reaction. The presence of a catalyst will speed up the rate of chemical reaction. The intensity of light will will increase the rate of photochemical reaction. So this influences only some types of reaction that we call photochemical reaction. There are reactions that are influenced by light. So it's not all reactions that are photochemical. So reactions such as photosynthesis, the reaction between hydrogen and chlorine, the reaction between methane and chlorine, they are examples of photochemical reactions. So the intensity, the amount of light available, the amount of photons given by the light, determines how fast or the rate of chemical reaction will be. The reaction will be. The nature of the reactant. So what are you reacting? Because each reactant has their nature. So some are naturally made to be slow. Some are naturally meant to be very reactive. Some substances are naturally reactive. Some are naturally inert. They are not very reactive until they are pushed. So these are the factors that do affect the rest of chemical reaction. I appear to have explained them in summary, but let's just see, look at it so roughly. So concentration, like I mentioned, when you say concentration, it's a measure of the quantity of the reactants. Okay. Okay. Let's do it this way. Let's do it this way. So for concentration is the amount of a particular reactant in the reaction system. The amount of it we have in a volume, in a unit volume of the reaction system. How much of the reactant is present? For instance, if you have a reaction between zinc and hydrochloric acid, which produces zinc chloride and hydrogen. So zinc is a solid, HCl is a solution, then a solution and a gas. So for this reaction, one of the ways to improve the rate of this reaction is we look at the reactants. Okay, if we can increase the concentration of HCl, how much of HCl is present in the solution of the HCl? Well, a HCl solution has a concentration. It could be that we have 0.2 mole of the HCl in every 1000 centimeter cube or 1 dm cube of the solution. So if we decide to increase its concentration to like 3, then it will increase the rate of the reaction. So the quantity of HCl in the solution, if we increase it, it will lead to, increase in the rate of chemical reaction. Because the more of the HCl you have, then it will improve on the collision. So the collision will improve, leading to effective collisions, and then eventually the increased rate of reaction. So that is where concentration comes in, especially for that reactant in solution. You understand? So then for pressure, pressure comes in when we have gaseous reactions. So we can talk about concentration of HCl in this reaction. When we have a reactant involving a gas, then we will not be talking about concentration of the gas. In terms, we'll be talking about the pressure. The pressure is like a concentration applying to gas when this applies to liquids or solutions. So for instance, if you have hydrogen gas reacting with oxygen gas, giving water, whether water in liquid form or in the gaseous state. So these reactions, pressure has effect on this reaction, not concentration. Because gases, the quantity of gases are measured in terms of pressure. So, but it is the same trend. If we can increase the pressure of either hydrogen or oxygen, then it will lead to increase in the rate of chemical reaction. So increase in concentration or pressure of the reactant will lead to increase in rate of chemical reaction. So it will favor, increased rate of reaction. So that is for concentration. Then we have the next one as what? After concentration, we talk about temperature. Temperature is the second factor we measure. So increase in temperature of the reaction system, when the reactions are taking place, it requires certain temperature for the reaction to take place. It's not every reaction that you just bring hydrogen or two reactions together like this in a container and the reaction will take place. It will not. So some reaction requires, there are reactions, bring it together, this reaction will start. For instance, if you bring sodium fuel, solid, in contact with even cold water, explosive reaction will happen quickly. You don't need to add heat. But some reaction requires that raise the temperature of the system to a certain level before such reaction can occur. For instance, the calcination, the, the, the composition of calcium tricarbonate into calcium oxide and oxygen will not occur until at an elevated temperature, like 900 to 1000. So once this temperature is provided, when the system is raised to that temperature, the reaction will start occurring. You understand? So, but generally, increase in temperature will increase the rate of chemical reaction. When temperature is increased, what happens? The rate of collision increases. The molecules of the reactant, they gain more energy, more kinetic energy. So as they go more kinetic energy, they gain more velocity. So the collision becomes faster, there is more energy, and then effective collision is achieved. Then before you know, the attraction energy is overcome and the reaction has taken place. So increase in temperature favors increases rate of reaction. Then we talk about surface area. Surface area. So surface area is a measure eh, of the size of the reactant. So how fine, like how fine is the reactant? How fine, like how powdery is the reactant? Or is the reactant present in a powder form, or it is coarse? You understand? It is coarse and not fine, like in lump. Like when the solid is present in the form of lumps, and when the solid is present, as granules or as powders. So these are different sizes. So in this case, the powder form, the powder, the grain or granular, the granule, then the lump. These are three different sizes. So the finer is the powder, then the next is granule, then the coarse is the lump. Then in terms of surface area, the one that has the highest surface area is the powder, is the finer, the one that has the smallest size. So the smaller the size, the higher the surface area, which means the surface area of this is the highest in terms of the surface area. Then followed by this, then the least is the lump. You understand? So the finer the size is, the higher the surface area. So and higher surface area increases rate of reaction because it's the major the exposure reaction happens by molecules. So when these particles involved are exposed, then the reaction will be faster. You understand? The reaction will be faster, but they have to be exposed to the particles of the other reactant, or they have to be exposed to the condition of the reactants, like a reaction that requires a pyroprocess reaction that requires heat. So heat needs to penetrate to every molecule needs to be heated before reaction can take place. So if you are using a lump, before heat could penetrate through all the molecules of the lump, it will take time. Then, unlike when it is powder, so all the particles are already exposed to the heat available. So quickly the reaction is going to take place. So that is why the higher surface area increase rate of reaction, and the higher surface area means you know that the side is very very small. You understand? So you can be given an equation in an exam. They will say like they will provide you a solid reaction. So and they will ask you a question of the rate of chemical reaction. Where is it highest? Is it with the powder, the lump, or your side? So the finer, the size, the reactant in the smallest side has a higher surface area. Take note of that. Don't look at the surface area as like how big the reactant is. It is how small the size is. So that is it. Then we have the next one, which is the presence of catalyst. We're not taking that one now. So let's treat the nature of the reactant. So nature of the reactant. So some reactants naturally, like I mentioned before, they are not active. You understand? Just like humans, some people are naturally sluggish. They hardly can, move. They are not active. But some people naturally they are energetic. They are virile. They are very active. So that is their nature. So if you are not active, sometimes there's nothing they can do. You understand? So sometimes how the natural inclination, natural activity of the reactants can affect the rate of chemical reaction. For instance, now we have zinc, then we have magnesium, we have aluminium. These are terra metals. Terra metals. So, but in terms of reaction, each of these can react with HCl, can react with HCl, can react with HCl. Okay? Or let's say, instead of bringing okay, let's say magnesium, aluminium, and gold, for instance, and gold. All right. So then let's use magnesium here, magnesium, then let's use gold. So each of these can react with HCl, leading to production of hydrogen and maybe the chloride of the metal normally. But the reaction is faster with magnesium. Then the next is magnesium. Is what? It's aluminium. It's much slower with aluminium than magnesium. But with gold, this reaction will never even occur. You understand? Because gold is very, very, unreactive. So this is the most reactive, followed by this. This is highly unreactive. So combining it with this, the reaction will not even take place, or it will take years, centuries to occur. So this because of the nature of the materials of the reactants. So that is that about it. So for active material, for reactive reactants, reaction rate will increase. Then we talk about the intensity of light. So like I mentioned, there are some reactions which we call the photochemical reactions. Photochemical reactions, the photo is taken from light. So there are those reactions that are influenced by light. Without light, they don't take place. An example is photosynthesis. You understand that. the how plant synthesizes the reaction that leads by which plant synthesize green plants synthesize their energy. So where they use water, carbon dioxide, which we breathe out, they combine it with water to form their energy glucose or whatever. So this reaction is a photosynthetic reaction. I mean, it's a photochemical reaction. It happens in the presence of sunlight. So then we have other examples like the reaction between methane and chlorine. You understand? So the chlorination reactions. So they are also photochemical. They are influenced by light. They happen in the process of the ultraviolet light, or the presence of light. So the intensity of light, how much of the light is available, because the light has to give what we call photon. So the more photon, it is now this photon that has the ability to initiate, to instigate the reactions. So how much of the higher the intensity of light, then the increase in the rate of the chemical reaction. Then finally, we talk about what we call catalyst, presence of catalyst. So when a catalyst is present in a reaction, then it has effect on the rate of reaction. So what is a catalyst? A catalyst is a substance which can alter, you understand, the rate of a chemical reaction. Of a chemical reaction. So a catalyst is like the enzyme in the body. So they are the chemical, the inorganic enzyme, while enzymes are the organic catalyst. You understand? So a catalyst is a substance that has the ability to alter, that is to change the rate of the chemical reaction. So it can speed it up, it can speed it down, or it can increase the rate of chemical reaction, it can decrease it. So mostly we use catalyst to increase the rate of chemical reaction. A catalyst, when it increases the rate of chemical reaction, we call it a positive catalyst. Then when it decreases it, we call it a negative catalyst. Because a catalyst is naturally meant, conventionally meant to increase, you understand, not to decrease. But there are still negative catalysts. So if you want a reaction to slow, to be decreased, the reaction rate to be decreased, then use a negative catalyst. You understand? So a catalyst is a substance that can alter the rate of chemical reaction. It can increase it, it can decrease it. So you can add this catalyst into, you know, into reactants, into your reaction. So at the end of the day, the catalyst does not partake in the reaction. Instead, it only helps in speeding up the reaction. And how does the catalyst speed up a reaction? It does that by eh, lowering the activation energy. The activation energy. So we mentioned that activation energy is the minimum energy required for a reaction to take place. So what the catalyst does is, if the activation energy, it brings down the activation energy so that the reaction can quickly occur. For instance, if a reaction requires like 20 megajoule, for instance, of energy to take place, catalyst can help in bringing it down to 5 megajoule. You understand? So the reaction can take place quicker, much quicker. That's what the catalyst does. It increases the rate of chemical reaction by lowering the activation energy. In a reaction profile, for instance, in a reaction profile, yeah, so a reactant has to overcome a barrier before it produces a product. Eh? This is the reactant. Before the product can be formed, this barrier is like a mountain that he has to climb before it gets there. So this peak, this height, which the reactant has to pass through before it gets to it becomes the product. We call it the activation energy, EA, the activation energy. So that's this maximum energy has to be overcome. You understand? Before the product can be formed. So from here, the reactants begins to change until it gets to the peak. At the peak, what that we call the transition point, or the activated complex. So at this peak, then that's the transition speed. So the reactant would have started changing into the product. Then it now becomes full product at this level. You understand? So this is the stage of transformation. So, but before this activated complex can be reached, then the activation energy has to be attained has to be overcome. So the height must be climbed. You understand? So that height, that barrier is the activation energies. So when we have a catalyst, so the catalyst will just help you to give you a shorter path. Okay, instead of having to climb this, it will take time to climb this and that. So because and it requires energy. So what is what does catalyst do? Catalyst will just help you move like this, sharp, a shortcut. So instead of having to pass through this, let us have a shortcut. It's just like the catalyst help you break down the mountain to it lowers it, or just find a path along the mountain and quickly go. So that is why we say catalyst help in lowering the activation energy, so that the activation energy will now, instead of having to measure from here to here, the activation energy now drops to just here. This is the new activation energy. This is activation energy number 2. This is number 1. Number 2 is for catalyzed. When we add catalyst for the catalyzed reaction, then for number 1 is for uncatalyzed reaction. So the activation energy for the uncatalyzed is higher. Then when you add a catalyst, it lowers it. You understand? It lowers it. Then you have a product. So this has to be understood. This is what we call this is the energy axis. Then this is the pathway, the reaction direction, the reaction pathway. So this is what we call energy profile, reaction profile. You understand? So this is what a catalyst does to help in the presence of a catalyst help in increasing reaction. We have different types of catalysts like zeolite. We can use platinum. We have platinum catalyst, especially in the reaction between hydrogen and oxygen. Platinum catalyst can be used. We have like vanadium 5,000 used in the industrial preparation of tetraspecific acid, which we call the contact process. Yes. So when in the combination of sulfur and oxygen like that to form the superoxide, we use V2O5 vanadium 5 oxide as a catalyst. So we have different types of catalysts. Mostly catalysts are in solid forms. You understand? They're in solid form. So at the end of the reaction, the catalyst is not chemically changed. It doesn't partake in the reaction. It may have undergo physical deformation like the color changes or whatever, but it does not partake in the chemical reaction. All it does is to help in speeding up the reaction. That is the catalyst. So there are certain things that can help, that can improve the activity of the catalyst. We call them promoters. And there are also certain substances which, when present in a catalyst, then they can weaken the activity of the catalyst. Then we call them inhibitors. So those are the other stuff that you may have to know. I think with this we can say we've done a lot, or we've done enough about rate of chemical reaction. So probably maybe in some subsequent class we solve questions on rate of chemical reaction. If there are calculations on determination of rate, then we'll solve it. Then maybe in similar topics, then we'll talk about like endothermic reaction, because this energy profile is for an endothermic reaction. And then if it were endothermic, it would have been the same. But the product arm will come below the reactant arm. So the reactant arm will be higher. That is for exothermic reaction, because exothermic reaction is a reaction that, where heat is evolved, that gives out heat to the surrounding. As the reaction is taking place, it's producing heat. You understand? Why some reaction, it has to absorb heat. You understand? Like that reaction, calcium carbonate decomposition, it's an endothermic reaction, so it requires heat. You have to keep applying heat as it goes. But there are some reactions which are exothermic, like the reaction between sodium and water, for instance. It's exothermic. It's a heat generating reaction, so such as called exothermic reaction. So they are, for those exothermic reaction, their energy change, enthalpy change is negative. For the endothermic, their enthalpy change is positive. All these we're going to do, let me share that some other times. So I think this is all we've got to do. As I say, thank you. So thank you. To try and read, follow and read.